Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on jet propulsion of a tank with an orifice. So in our last lecture, we have discussed the theory part of this about the jet propulsion of a tank with an orifice. In this lecture, we'll solve a problem on that. So the question I have taken here, the head of water from the center of orifice which is fitted to one side of the tank is maintained at 2 meter of water, and the tank is not allowed to move, and the diameter of orifice is 100 millimeter. Find the force exerted by the jet of water on the tank and consider CV equal to 0.97. If the tank is fitted with frictionless wheels and allowed to move, then determine the propelling force on the tank and work done by propelling force per second and the efficiency of propulsion. The tank is moving with a velocity of 2 meter per second. So this is the question given, or I've taken the question from the book. So we need to solve by two conditions: when the tank is not allowed to move, again when the tank is allowed to move. So these are the two conditions are given. So for these two conditions, we need to find out the force exerted by the jet of water on the tank and here propelling force on the tank. Okay, so let's find out what are the data given and how to find out the answer. So the concept is very simple. If you have seen the last theory lecture, you can easily do the problem. So in the solution, let me write out what are the data given. First line, you can see the head of water is given. So H is given 2 meter, and the second line it is given diameter of orifice. So diameter of orifice D equal to 100 millimeter, and this one we can write this is 0.1 meter. Once diameter of orifice given means we can find out the area of the orifice, which is nothing but pi by 4 d square, and this is nothing but we can calculate like pi by 4. If you consider 3.14 and divided by 4 into d square equal to 0.1 square, then 3.14 by 4, which is nothing but 0.75 or 76 will there, 7.77. This is 0.1 square, 0.001, and you just multiply this one, then we can get near about 0.0078. Near about this will get the value of area. Then the next line, the CV value given. This is coefficient of velocity 0.97, and here we need to find out first condition. What we need to find out the force exerted by the jet of water on the tank. So here we need to consider that tank is not moving, it is in fixed condition, and the velocity of water, how much we need to find out. So then only we can find out the force, because in our last lecture we have seen the force exerted by the jet of water on the tank. This is nothing but rho a v square. Now this is the formula we have seen in our last, we have determined in our last lecture. So here if you see, area is calculated. Now rho value actually nothing but density of water. This is water liquid given, so density of water is nothing but 1000 kg per meter cube. Okay, now what is the unknown term is in this equation? Velocity. So velocity of this means actual velocity we can find out by the equation of CV into root over of 2gh. So CV value given, this is 0.97 into root over of 2 into 9.81 into velocity into head is nothing but 2 meter. So we can calculate this 0.97, and this is root over of 2 into 2 4 into 9 36, and this is 8.81. so 9.81 into 4 is equal to root over of this multiply 0.97. So this much 6.076. So here we'll get some value of like 39 point something. So finally we'll get v equal to 6.07 meter per second. So this is the velocity. Now put this value in this equation, so we can find out the value of force. So which is nothing but 1000 into area 0.0078 into this 6.07 square. So finally we can get the value of force exerted by the jet of water on the tank. So let's find out here. So this is already given. Let's square of it, multiply. This is 1000, and again multiply 0.00 287.98. So near about 288 we can consider here. So this is F equal to 288 Newton. So this is the force which is exerted by the jet of water on the tank when the tank is not allowed to move. But when you feed or when you fix some frictionless wheels in the tank can start moves. Okay, so that means this is the tank is there, and in this here orifice is there, water is coming out, and this is the head of water, and here we have like fixed some wheels there. Due to this impact of this velocity of jet, the tank started moving in the opposite direction as per the Newton's law of third law. Okay, so in this condition we need to find out what is the propelling force. So for this condition, if you see, all the data need to be taken same, but here the extra part is given, that is velocity of the tank. So that one we can consider. That means the tank started moving here. This is u, and this is the velocity of jet v. Okay. So at this point, like at this location, the water is coming out with the velocity of v, and this is our head of water, height of water. Like at the up to this level, water is there. So tank you can you can do a little bit more height like this. Okay. Now for this condition again, let u equal to 2 meter per second. For this condition, we need to find out, as I told you, the second one. This is the first one. We can give. Second one is the propelling force. So propelling force we have derived in our last equation in our last lecture. That is nothing but rho a. This is v plus u into v. This is the formula, because there we have taken the relative velocity. So in this condition, we can write this is 1000 into area. Area of the orifice already we have calculated 0.78, and this is velocity 6.07 plus 2 into 6.07. So here we can find out the value of fx. So let me find out this. Now this is not required, so we can write this is 1000 multiply 0.0078 multiply 6.07 multiply 8.07, 382.08. So this one we can write 382.08 Newton. This is the force, propelling force. The third one is we need to find out the work done. Work done by the propelling force per second. Work done by the propelling force per second. So this is nothing but we know that fx into the velocity u. So how much we got into velocity? Just multiply it two times of this. So that means 764. So our 764.16. 764.16. This much Newton meter per second. Because we have seen this is force, this is the velocity. So force is here Newton, velocity equal to meter per second here. So we'll get this one. Now the last one is efficiency. So efficiency of the propulsion, we have seen the formula. The formula is like 2vu divided by v plus u square actually. This is the formula was there. Now we can write this value 2 into velocity. This is 6.07 into velocity is of the tank 2, and here we can write this is 6.07 plus 2 whole square. So finally we can find out 4 into 6.07, that is nothing but 24 or 24.28. we get like this. This is 4 into 6.07, 24.28, yeah, divided by this is 8.07 square, which equal to 0.3728. So we can write the efficiency here 0.3728. Okay, or equal to, you can write in terms of percentage, that means 37.2%. This is the efficiency. Okay, so these are the formula. Based on this formula actually we can find out the answer. So we need to remember this formula, or if you are not able to remember the formula, we need to know the concept of this jet propulsion when it is applying on a tank. So this is efficiency, this is the work done per second, and this is the force the propelling force or a propelling force on the tank, we can say, when the tank is started moving. Okay, and this is the formula of force exerted by the jet of water on the tank when the jet tank is not moving. This is the difference between this force and this force. I hope you understand this problem. Still, if you are having any doubt on this, you can give a comment on the comment box. Thank you all.